Hello guys, welcome to Kung Fu Fog. My name is Alec. Well, it's time for us to solve another Leetcode question today. It's 542.01 matrix. It is a very interesting problem, and I am going to share some of the techniques after we have solved it. But first, let's take a look at the question. Given a matrix consists of 0 and 1, find the distance of the nearest 0 for each cell. So the distance between two adjacent cells is always 1. So given us an example like this, in simple words, the goal of this question is to try to find the shortest distance, starting from those ones by reaching to its nearest 0. Okay, so when you first receive the question, the first solution come into your mind probably will be BFS or DFS. Either way, it's fine. So that's the typical way of solving those questions. In this example, I am going to use BFS. So in order to use BFS to solve this question, we will have to use a queue to search through the matrix, right? So without further ado, let's dive in to write some code. Okay, so first thing first, we are going to calculate the rows and index. Rows index and columns index. Rows equals to matrix dot length and columns equals to matrix 0 dot length. So in an interview, typically you will probably have to check those bounds, the rows and columns, to see if those matrices are empty or if this matrix is null. And if the situation happens, then you don't have to do anything. So you are free to check those bounds, but in this example, I believe there should be answers. So we're gonna skip those steps. Like we discussed before, we are going to use BFS, so we will need to use Q integer, and Q equals to new linked list. In Java, Q is represented by using the linked list. And before we have searched through the matrix, we will decide where to search from. In this case, I'm going to search from those zeros. But 99% of the time, we are going to search through those ones. And trust me, you are right and it's reasonable. And we will discuss more about it, why we will search from those zeros. For now, just bear with me and we're gonna write some code to finish this problem. I less than rows and I plus plus for j equals to 0, j less than columns, j plus plus. If, let's take a look at this value. If it's 0, like we have discussed, we're gonna search from those zeros. We will put it into our queue. How we want to put it, I am gonna use some index, which is I plus columns plus I multiply columns plus j. It is actually a formula to what we use a technique which I will share with you at the end, that's called dimension reduction, which is to reduce two-dimensional arrays or two-dimensional matrices, those index two-dimensional index into one-dimensional index. And else, if maybe we should chat 1 second. There are only two elements in the matrix, so if matrix ij is 1, then I am going to modify its value. So matrix ij equals to integer dot max value. This is very beneficial in this way of solving this question because we are forcing it to update the nearby values guarantee. Well, we have done our preparations. We have put all the zeros into our queue, and we have modified those ones into the maximum value of integer. Now we are ready to search. So I am first going to create an array. I call it direction dir, which is direction, because for BFS we're gonna search through the 4 directions: up, down, left, and right. So 0, 1, 0, -1, 0. Why are we using this array? You'll find out later. So while typically in BFS is to check the queue at QUEUE is not empty. Then we're gonna pop out the first element, which is, we call it top, equals to q.poll. And it's very interesting. The method is offer and poll, and it's not push or peek or something like that. So probably some of the methods you have to remember. And we're gonna traverse, or we're gonna look through the direction array. In k equals 0, k less than third length minus 1, k plus plus. Why is -1? Because I am going to form 2 indexes into one group. So 0, 1, 1, 0, 0, -1, -1, 0. And I don't want to go for index out of bound, because if I don't -1, there would be 0 and some other value is index out of bound. And that's not the thing that you want to happen. So first we want to get the original 2-dimensional index, because we have done a dimensional reduction here. So new index, or row index for the position we want to start searching from, is top divided by columns plus dir k, and then the column index is top modular columns plus directional k plus 1. So in this way, 2 elements form a group, which means the row index plus 0, the column index plus 1. Guess which direction we are moving to? We are moving to the right, and you're right. So I'm gonna make some comment here. So new row index, and this one is new column index. The new position that we are trying to search from in the matrix. Once we have the new index for the position that we want to search through, we need to check the conditions to update the matrix value, because here we have modified its original value to the maximum value of integer, and we need to change it back, because now we are searching from those zeros. Every adjacent cells, it just one step away from 0. Then we need to update it. If x is greater than 0 and less than rows and y is greater than equal to 0 and y is less than columns. So these are just the basic condition checks to see if the new row index and column index is within the matrix, is not indexed out of bound or something like that. And the other condition we need to check is to see the new position x and y. We don't want to search those 0 again to see, only if it's greater than 0. Means, for example, here if we are starting from 0 and the adjacent cell is 0, 0, right is 0, and then we don't want to search it because we have put it into our queue already. We only want to search those adjacent positions which are not 0. Makes sense, right? And the other condition we need to check is see if this new position we are searching from, it's one step further away from its original position, which is original position is top columns top modulate columns plus 1. So this part gives us the original value of the positions that we came from. Plus 1 means it's one step further. So this gives us the new value or new positions value. Means if the new positions that we are currently on is one step further than the original one, means it's closer to come from this position to this position. So we need to update it. Makes sense, right? I probably want to, let's see, move it down. This looks ugly. Let's maybe here. Much better. Okay. So, like we discussed before, we have satisfied those conditions and we want to update the matrix new positions value to the old position plus 1 because it's closer. And then we need to put it back to the queue again for the next round search. It's matrix, oh no, that is queue.offer using our formula x multiply by columns plus y. And we pretty much done. So we return to matrix. See if there is any compilation errors. There is one. So j equals 0, j, let's see, what does it say? Variable j. J colon j plus plus. Cannot find symbol. Line 8. Oh, there is no initial declaration. What was I doing? Can't believe it. So let's do it again. Okay, no errors. That's a good sign. Looks right. Let's submit it. Wow, boom. The question solved. No errors, and it's accepted. The time efficiency, it's okay. The space efficiency is also alright. Let's forget about it. So we're gonna talk about the techniques we are using in this question. So we were using 3 techniques in this solution. First, when we first received the matrix right, 99% of the time, believe me, trust me, we will start from those ones because reasonably thinking, ones are our targets. We probably will decide start searching from those ones. But by doing this, we will have more things to do, such as to have some ways, some sort of ways to remember how many steps we have searched to. And we have to remember or record those shortest distance and then update it. But by doing it, by searching through the 0, we don't have to do that. And we only need to update it one step at a time to update whatever the adjacent, the near round cells that near the 0. Hope it makes sense to you. So the second technique here Notice I use Q and we only put an integer inside the Q. But the question is, the matrix has two index, right? Very important, the row index and column index. And typically way of solving it, we probably want to create a class such as point that will be two fields inside the row index and column index, and then we put the point class into the queue. So each time when we pull out one element from the queue, and then we extract those two elements out. And we don't have to do that neither, because we use a technique called dimension reduction. By using the formula here, I multiply columns plus j, which is the column formula is row index times columns plus column index. And it's very useful in most of the situations. And it's very simple. You don't have to create an extra class just to solve this question. You can just reduce the dimension, two-dimensional index into one dimension, and that's enough. Right? Pretty smart. So the third technique is this array. Is how we use simple ways to decide or to let us to start searching from four directions. And this array looks like very simple, but it contains the critical information for us to search from. For example, we're gonna group two indexes together. 0, 1 means we're gonna zero row index plus 0, column index plus 1 means we are moving one step to the right. We are moving right. 1, 0 is we are moving down. So 0 minus 1, we are moving, guess, left, right? So minus 1, 0, we are moving up. Clever, right? Four directions into one array. We just need to look through the array and then we get four directions by plus dir k and dir k plus 1, then you are done. Impressive. So these are the three techniques I want to share with you today, and I think it's pretty helpful. And one more thing I want to mention before I close this video is we are modifying the value here in a production environment. We are not suggested to do that, and probably you will want to explain to your interviewer saying, okay, we are not supposed to modify the matrix value here in production code because someone else might also be using it, but I am just using it here today. If we don't want to use it, we can copy another matrix to modify it there. Then the interviewer will know, okay, you have concern about it in a production mode. Then you are great. So that's it for today, and hope it helps, guys. I will see you in our next video.